Hello viewers, welcome to Film Global Academy. And I'm your favorite teacher, Fredmark is my name. Once again, you are welcome to the class, and I'll be talking about identification and uses of measurement. In our last class, we talked about what measurement is, the fundamental quantities and the derived quantities, the differences between these two quantities and their units. But this morning, we're talking about how to identify these measurements and what are their uses. Remember, in the last class, we talked about the three most important basic quantities in physics, and they are mass, length, and time. The three most important basic quantities are mass, length, and time. And then this morning I'll be talking about the measurement, the instrument that we're using to measure these things and how they can be used in the lab and in the society at large. I want to start with length. If you want to measure length, for instance, a carpenter who wants to measure the length of a wood will not need to use a broomstick or let's say a spoon to do the measurement. You use what we call a tape to measure, and the tape which a carpenter uses in measuring wood is different from the one the tailor uses in measuring the length of a material. And now, if we come back to science, come back to physics, now in the lab there are instruments that are used to measure length. Number one is meter rule. Meter rule is on the board there, a meter rule. The meter rule is an instrument to measure length in the lab. If I want to measure the length of this blackboard, for instance, I have to use a meter rule. In the layman we call it ruler. The one you have in your marset is a ruler. You can say if you have the other ones that are wooden or plastic in nature, you can use it to measure length of your, maybe you are drawing margins in your graph or drawing your margin in your notebook, you use ruler to draw. But in the lab, you have bigger length, a longer length you want to measure. You cannot use that small ruler, so you use what we call the meter rule. Meter rule is an instrument for measuring lab. Meter rule. Rule. I think it's RE, sorry. Meter rule. Meter rule is an instrument for measuring length in the lab, and it can measure length. It's mostly have a graduation of between 1 millimeter to 0.1 centimeter. It could be 1 millimeter or 0.1 centimeter. So I want to measure the length of, let's say, the table in the lab. Let's say a liter stand in the lab. I want to measure the actual length of that liter stand or that table. I have to use what I call the meter rule, and it's ranging from 1 millimeter or 0.1 centimeter. Measuring length in the lab using meter rule is quite accurate, but sometimes there are lengths that you cannot measure using meter rule. Take for instance, I want to measure a rod, or I'm holding a marker in my hand and I want to measure the length of this ruler. If I use a meter rule, because it is round in nature, I will not be able to measure the length of this correctly. So it is not very accurate to use a meter rule to measure an object that is round or cylindrical, for instance, or a tube. You know how a wire looks like. If I want to measure the length of a wire, I cannot use meter rule. I have to use another instrument to measure it. Now, let's go on. The meter rule is on the board there. It has 5 small lines before the very thick line. So they are ranging from between 5, 10, 15, 20, 25, until it gets to 100. It's quite very big. And then we have another instrument to measure length, like I was saying, an instrument that is not straight in nature. I want to measure the length of a tube, for instance. I will not use meter rule. I have to use another instrument called the vernier caliper. Vernier caliper. Sorry, it's I-E-R, vernier caliper. Sorry, dear. Caliper. 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 If I want to measure length that is not straight in nature, I will not be able to use meter rule. If I want to measure the length of a tube, or the length of a rod, or the length of this marker, for instance, I will have to use a meter rule because I will not get an accurate reading. So I have to use an instrument called the vernier caliper, or a micrometer screw gauge. You will get there. But the vernier caliper is used two types. We have what we call the engineer caliper, which is used by the engineers for measuring length of a shape that is not straight in nature. And if you look at your screen, the instrument is there. And then we also have the vernier caliper. It's an instrument that we use in the lab, in the physics lab, to measure length. Now, this vernier caliper is more accurate in measuring length than the meter rule. The vernier caliper is more accurate than the meter rule. It also has a graduation of, say, from centimeters to millimeters, or millimeters to centimeters, as the case may be. And it has two scales. The vernier caliper has two scales. It has a jaw, from the diagram you see in the screen. It has the two jaws. And those two jaws is used for measuring length in their different scale. You have the main scale and the vernier scale. The main scale and the vernier scale. Under vernier caliper. Under vernier caliper. It has two scales, the main scale and the vernier scale. The vernier caliper has two scales, the main scale and the vernier scale. And then we're going to be learning how to use them to measure length. Now, from the diagram you have seen on the screen, you see that the vernier caliper has a smaller part in the main scale. A small box in the main scale is on the screen there if you want to see very closely. Now, let's assume I want to measure the length of a rod. The length of a rod. Okay? Remember, I was talking about length. So let the length still be there. Now, the length of a rod. Remember I said it has two scales, the vernier scale and the main scale. Now this is the main scale. It has 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Now in the main scale, the main scale is in centimeters. The main scale is in centimeters. I notice that it has 4 small lines before the major lines. 4 small lines before the major line. Now, if I have, let's say, 5 here, and I have, let's say, 6 here, so that's going to be 7, 8, 9, and 10. Now this is the main scale reading in the vernier caliper. Now I want to take the vernier caliper reading from the main scale. Let's assume it starts from here. In the vernier scale is in millimeters. The scale is in millimeters. This is the main scale. And this is the vernier scale. The vernier scale has 9 small lines. 9 lines. 9 lines. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Nine lines inside the vernier scale with a one big line that is in 5 millimeters. 0.5 in, remember I said that the standard unit for measuring length, distance is in meters. So if I have my readings in millimeters, I have to convert to centimeters because the main scale is in centimeters. So I have to convert from millimeters to centimeters. And if I have it in meters, I have to convert from millimeters to centimeters and then to meters. Now, if I want to take the reading now on this scale, take for instance, I measure the length of a tube. Remember, the tube has both an inner tube. The tube has a hole, it has hole. So I can't just measure the external length, I could also measure the internal length of that rod or that tube. So I place my vernier caliper at the edge of, because it has two jaws, at the edge of both ends and screw down tightly. The reading, as you tighten it, the reading will show. So when you bring it out, there's a two scale in the vernier caliper, which is the main scale and the vernier scale. Now take for instance, this is what I got after screwing it in my rod to check the length of the internal length of the rod. Now, I have this, and I have to check. The first thing I need to do is to check. Where does the main scale enter into the vernier scale? When does the main scale enter into the vernier scale? Now, if this is 5, this is 6, it means this is 5.2, 5.4, 5.6, 5.86. So in the lines is now 0.2 centimeters. So if this is 5, for instance, this is 5 on the ball. So that means this first small line is 5.2. The next one is 5.4. The next one is 5.6. The next one is 5.8, and then 6. 6.2, 6.4, 6.6, 6.8, 7, 7.2, 7.4, 7.6, 7.88 to the ending. Now, for instance, we have, if this is supposed to be 10, let's assume this is 10. So this one will no longer be 5.2 because 5.2 to get to 5.8 cannot give you 10. So that means if here is 5, here you will have what? 6, 7, 8, 9, 10. This is 5. So this one becomes 6, 7, 8, 9, and 10. So it depends on how the reading is, the caliper reading is. If I have 6 here, that means the small lines is 0.2 centimeters. But if I have 5, 10, next one will be 15, 20, 25, 30, as the case may be, that means the small lines is 1 centimeter. So if this is 5, this is 6, 7, 8, 9, and 10. So we are back to where we were doing before. So this is 6 for this question, and I have to find the caliper reading from this question. Find the caliper reading, or find the length. Rather, find the length of the caliper. Find the length of the caliper. Now, the first thing I will do is the main scale. So when I say MS, it means what? Main scale. So MS is where does my main scale enter into the vernier scale. So if this is 5 and the next line is 5.2, remember if you watch this thing very closely, see that the line is not exactly on the first line, is in the space between 5 and the next line. So this, if this is 5, here becomes 5.1, 5.2, 5.3, 5.4, 5.5, 5.6, 5.7, 5.8, 5.9, 6. So if that's the case now, the next scale now is at 5.1. I will now write 5.10 centimeter. It has to be on 2 decimal points. 2 digits in decimal point. The main scale is now 5.1 centimeters. 5.1 centimeters. Now, the next thing I need to do is to find the vernier scale, VS. So when I say VS, it means vernier scale. The vernier scale now, this is why we have to be very careful when you are checking the value in the vernier scale. What I need to do is to find where does the line in the vernier scale coincide with the line in the main scale. Where does the vernier scale, the line in the vernier scale, coincide with the line in the main scale? Now, take for instance, I have to trace it. You trace and trace and trace and trace and trace. When I use the word coincide, where does the main line touch? Where does these two lines, the main scale and the vernier scale, where does the line touch? Where do they meet? That point is where you take your reading from. So at this point, I think it's on 7. Even on 8, no. I think, okay, it's not exactly on 7, it's here. So the vernier scale coincides at this point. Remember, if this is 7, this is 7.2. This is now what? 7.4. 7.4. So the vernier scale is coinciding with the line in the main scale at 7.4 millimeters. 7.4 millimeters. But I have to convert it to centimeters. So I divide by 100. So 7.4 divided by 100. 7.4 millimeters. That is where the main scale coincides. The line meets at the vernier scale. So what I need to do is to convert from millimeters to centimeters. So dividing by 100, I have 0.074. 0.074 all now in centimeter. Now I have to add it together. So I have 5.10 plus 0.074. So I have 4, I have 7, 1, 5. So the vernier scale, the vernier scale reading, now the reading becomes 5.174 centimeters. So you see, at this level, you cannot use this, you cannot measure the length of a tube, or the length of a bulb, or the length of let's say a rod using meter rule. I can only measure the length of, let's say, the length of the blackboard, the length of your table in the lab, the length of your equipment, let's say from A to point B. Take for instance from point A to point B in a straight line. So where I can place my ruler perfectly on that instrument to measure correctly. But if I have something like a ball, a rod, a tube that is cylindrical in nature, I cannot use meter rule. I have to use the vernier caliper. The vernier caliper measures more accurately, and I said it has 2 scales, the main scale and the vernier scale. And we have talked about how can we now measure using, take for instance, I have to measure the length, it has 2 scales, and then I have to check how do I now measure when I know it has 2 scales. And the first scale is checking where does the main scale enter into the vernier scale. From my own here is entering at 5.1 centimeter, and I said that in the main scale it is in centimeter, it is ranging or graduation is in centimeters, but in the vernier scale it is in millimeters. So how do I do that? Is to check where does the main scale line coincide, where does these two lines meet. They must meet at a point. At that point, you check the reading from there, and remember it's in millimeters, so I have to convert it to centimeter. They can both be in centimeter. We don't have different reading, 1 centimeter, 1 millimeter. No, we have to convert completely to centimeter, or convert it completely to millimeters, not reading them differently. So when we read that together, we're having 5.17 as the reading on this scale. I think it's clear. Now, if you have to, remember I said also that another instrument for measuring length, you have the engineer caliper. Those are under the umbrella of the caliper. The vernier caliper is there. They have the longitudinal caliper. Those ones are used by the engineers to still measure length that are not straight. You know, engineers, they deal with most of the time with pipes. Let's say length of the wire in between, like those who work in the oil sector, they have to do with pipes. Those who work in any shape that is not circular in nature. So they do not have what we call the linear caliper. It has two jaws also on the screen there. It has two jaws. So both ends, once they measure it, they place it on the meter rule, or something like this. It has two jaws. So it just being placed on the instrument that you want to measure. The two jaws. Place one of the jaws to the one end and the other jaw to the other end. No matter how big it is. So when you place it there, you move. When your make sure it's properly tight, and then remove both edge of that caliper, and then place it on the meter rule. Place it on the meter rule. Now, place it on the meter rule because the caliper does not have a reading, does not have a rule, or let's say if the vernier caliper is inside the caliper, it has a meter rule attached to it that you can read from. But the vernier caliper does not have such thing. So you have to remove the caliper from the instrument you're measuring and place it on the meter rule. Place one edge. Let's assume after measuring the length or diameter of an apparatus or an equipment, and I place it on the meter rule. And one of the edges is at 3 and the other end is at 8. You can start from 1, depends. Just say I place it on 3 and on 8. And then I want to find the length of what I have measured. Now remember, I will not just say the length is now 8. When I do that, I am very wrong. Because it's not starting from 1. If I say the length is at 3, I am very wrong. What I need to do is to find the distance, find the length, the length between here and here. So if it's at 3 and it's at 8, so between here and here is 5 centimeters. It's 5 centimeters because 8 minus 5, 8 minus 3 is 5. So the length of whatever I have measured using my linear caliper is now 5 centimeters. It's 5 centimeters. Just place the jaw of the caliper on whatever equipment you want to measure, whatever apparatus you want to measure. Place it there. Those ones are used by the engineers, so they know. When they place it there, they remove it, remove the make sure you don't adjust or reduce. Then place that jaw on the meter rule. When you place it on the meter rule, so the left, one of the jaw is touching one point, the other end of the jaw is touching another point. So check the distance, the difference between where the first jaw and the last jaw is. So on the board now we have 3 and 8. So the difference between these is 5. So the length of whatever I have measured is now 5 centimeters. That is in the case of the engineer caliper. It's used by mostly the engineers. Or what we use in the lab, in the physics lab to measure length, the one we have the meter rule, of which some popularly call it a ruler, but not we don't use the smaller ruler in the lab because whatever I want to measure is bigger than the length of your notebook or the length of your masset. So we are having longer lengths. So we are using meter rule. And then vernier caliper is also an instrument to measure length. The vernier caliper is measuring length or the diameter of objects that are not straight in nature, like a tube, like a rod. The diameter both in the internal and the external. And I said it is more accurate than the meter rule. Now, if also another one is micrometer screw gauge. Micrometer screw gauge is another instrument that we use in the lab to measure the diameter. The diameter is also length. The diameter of an apparatus, or diameter of a rod, or a tube also, but this time it has to do with the external, the outside. Only the outside. I want to measure let's say I want to measure the diameter of this marker. I have to use the micrometer screw gauge because I'm not dealing with the internal. I want to use internal. I will not have to use the vernier caliper. Vernier caliper can measure both the external and the internal, but the micrometer screw gauge can only measure the external diameter of an object. So I said now, micrometer screw gauge is another instrument for measuring diameter of an object, most especially the external part of the object that is not straight in nature. It could be circle or it could be cylindrical, not properly circle. Such instrument can be measured using the micrometer screw gauge if it's the only external aspect of what you want to measure. And it also ranges, it also has a graduation of millimeters and then also centimeters, just like the meter rule and the vernier caliper. They all have a graduation of millimeters and then centimeters. They could measure in millimeters and in centimeters. Now, the micrometer screw gauge also has two scales. It has the main scale and the micrometer screw gauge scale, or we also call it the vernier scale, as the case may be. The main scale and also the vernier scale. It has two scales too. The vernier scale. So when you have the instrument, it's there on the screen. So when you place whatever you want to measure, let's take for instance, I want to measure the diameter of this marker. So I place my micrometer screw gauge on the marker, then make sure it is properly tight to hook this thing. So without me holding the marker, it could stand on its own firm. So I can, and in that micrometer screw gauge, it has two scales, the main scale and also the vernier scale, which is the micrometer screw gauge scale. So you are able to check the reading. It has to have the same way we measure it using the vernier caliper is also the same way we measure in the micrometer screw gauge. But the difference is that this one can measure smaller length, no matter how small the object is, no matter how small the length is, the micrometer screw gauge can measure it, as long as it is something that can be hooked to the apparatus. It can measure the length of that object. Now, I want to let's take a question and say, how can we now use micrometer screw gauge to calculate, if I want to calculate the diameter of an object? Now, I said, like we were discussing, and I said that the micrometer screw gauge has two scales, the vernier scale and the main scale. The vernier scale, which is representing the micrometer screw gauge now in micrometer screw gauge, but we can also still call it the vernier scale because it has two scales. The same way it is being read in the vernier caliper, the same way it's going to be read now in the micrometer screw gauge reading. Now, for instance, this is a question on the board, and I'm asked to find. Is assumed that an instrument micrometer screw gauge has been used to measure the diameter of an object, and this because it has two scales. The first scale is reading this, the second scale is reading this. The main scale is reading this, the vernier scale is reading this. So I'm asked to now find the reading of this micrometer screw gauge. What is the reading? What is the reading? What is the reading of this micrometer screw gauge? Now, first and foremost, remember that the main scale is always in centimeters. The main scale is always in centimeters, and the vernier scale is in millimeters. Now, what do I need to do? If this place is 7, this is 8, this is 9. Now, what is this? What number is represented here? So if this is 7, this is 8, it means this one is 7.5. It means 6.5 is somewhere there. So if this is 7, we have 7.5, this is 8, 8.5, 9, 9.5, and then as the case may be, 7, 7.5, 7, 8, 8.5, 9, 9.5, and the end. Now, if that's doing that, if this is 7, this is 7.5, which means this is also 7.1, and this is 7.2. The next one is 7.2, 7.3, 7.4, 7.5, 7.6, 7.7, 7.8, 7.9, 8. So if this is 8.5, it means this is 8.1, 8.2. Even if you are not told, looking at the scale, you should know that if this is 7, this is 8, which means half of it. The half of 7 and 8 is 0.5, which is 7.5. Now, in between 8 and 9 is 8.5. In between 9 and 10 is 9.5. So if here is 8.5, it means, sorry, 7.5, it means this is 8, 7.6, 7.7, 7.8, 7.98. Now, let's start. The main scale. How do I now read the main scale? What is the reading before the main scale enters into the vernier scale? Remember, the last number before it enters into the vernier scale. If this is 9, this is 9.5, 9.6, 9.7, 9.8, 9.9. 9.9. So the main scale is at 9.90 centimeters. 9.90 centimeter. Now, if you are doing practicals, you have to make sure your reading must be at least 2 to 3 decimal points. Don't just leave it at, say, let's say 9.9 and the next one becomes 9. Let's say you're taking a reading in the lab and then you have the first reading at 9.9. The second one is 9.42. Another one is 9. Let's say 124. It's arranged haphazard. So the best is make sure they are all in the same digits. If I have 2 here, I have 2 here, I have 3 here. Okay, I can make it 3. Add 0 here and add 0. So it becomes uniform. It becomes uniform. So that is that. Now, back to what we are doing. Now, the main scale is entering the vernier scale at 9.90 centimeters. Now, the vernier scale, the same thing happens. The same way you read the vernier scale and the vernier caliper, you have to check where does the main scale enters. Where does the main scale, the last line, where does it enter? Where does it coincide? Where does the main scale coincide? Now, there should be a line here. There's a line demarcating your literal. Now, I have to check where does that main line enter, coincide, meet at the vernier scale. These are the 2 points, but it's meeting this central line is meeting at 10. Remember, I said it's in millimeters, so I have to convert it to centimeters. So I have 10 millimeters. So when I convert to 10 divided by 100, when I convert, I have 0.1 centimeters. So what is now the actual reading? The total reading, the actual reading. The actual reading is now, let's say, for the sake of the board, we have 9.90 and 0.10. So when I add it together, I have 9. So this is 0. Let me add from here. 0.01. That's a 10. So I have 10.00. 10.00 centimeter. Now this now becomes the actual reading. The actual reading on the vernier scale. The actual reading on the vernier scale. The actual reading on the vernier scale. Remember, I said this is in millimeters, centimeters, and the micrometer screw gauge scale is in millimeters. Now, if you look at the way the shape is, the vernier scale, the vernier caliper's reading on the question is different from the diagram in the micrometer screw gauge. So when the question is going to come, it's going to come in this form. When it has to do with micrometer screw gauge. But the other one we did first, that has to do with a meter that's into 2 different scales. That's how the question comes when it comes to the vernier caliper reading. So you can be able to differentiate it. But the same way you calculate this and calculate that, all you need to do is to check where does the main scale enters into the vernier scale. The last number before it enters into the vernier scale is the reading on the main scale. Now, which in the vernier scale or the mechanical scale gauge, where does the line coincide from the line in the main scale? Where does it coincide with the line in the vernier scale? Whatever I have here, remember, is in millimeters, so I have to convert to centimeter. Now, something I forgot. This is 5. So if this is 5, this is 10, this is 15, this is 20, and then the other will be what? 25. So it's now really the 5, 5, 5, 0.5 range. So if here is 5, that means here is 6, 7, 8, 9, 10. So if, for instance, it coincides at, let's assume it coincides not here and it's coinciding here. Let's assume it's coinciding here. It is now at 9. Not because I'm reading, not because it is written out boldly 5, 10, 15, so it becomes easy to calculate. But what if the line is coinciding at the last small line before the major line, which is 10? So remember, if this is 5, this small line, first one is 6, 7, 8, 9, and 10. So it's coinciding at 9. So it means I have to still divide. I have to still convert it to centimeters. So if it's 9, it's now 9 divided by 100, which is 0.9. And when I add it together, I'll have about 9.9 centimeters. So the most important thing is for you to know how to convert your millimeters to centimeter. But don't forget that the standard unit for length or for distance is in meters. In physics, your SI unit is very important. Your SI unit is very important. It could be in centimeters, it could be in millimeters, but the standard unit for length is in meters. But in this case, since it is in centimeters, you are leaving your answers in centimeters. But it has to do with other things that the end point is in meters, you must convert. Very, very important. SI unit is very important. You should miss it. If, for instance, I have, let's say, 10.0 centimeter, and if an objective question, it could come in 10, the A is representing 10.00 centimeters, and the other one is saying 10.00 millimeters. So that the SI unit is not different, but they're having the same answers. They're having 10 millimeters, they're having 10 centimeters, they're having 10 meters. So you should be very careful when you are calculating when it comes to units. So once you have missed the unit, you have missed that answer. So if it's in theory, the question comes in theory, when a child is answering the question in theory, and peradventure he misses the SI unit, it's very wrong. But every step you take, there's a mark for it. But if it's an objective question, once you have missed the SI unit, you have missed that answer. So if I have, for instance, 10.0 centimeters and I have 10.0 millimeters, and once we shake 10.0 millimeters, the answer is already wrong. So you must learn how to convert from millimeters to centimeters and know the standard unit for every measurement you are measuring. Now, okay, let's round up what we're doing for today. Now, remember I said that the instrument for measuring length in the lab will have the meter rule, we have the caliper, and the caliper we have a generic caliper, we have the vernier caliper, and then we have the micrometer screw gauge. Now, let's talk about, I said the most important basic quantities in physics are mass, length, and time, which I gave when I started earlier. And then I said, now, mass. Mass, the instrument for measuring the mass of an object in the lab, we use what we call the spring balance. Spring balance. Spring balance is an instrument to measure the mass or the weight of an object. So, for instance, some people use chemical balance. It is in the chemistry lab. I want to measure the mass of a chemical substance in that chemical. I have to use what we call the chemical balance. But in the physics lab, we use the spring balance to check the weight or the mass of an object. Now, take for instance, as I am now, I want to check my weight. You don't have to use a spring balance. I have to use a scale, which the hospital people use. You go to check your weight in the hospital or in the gym house. You use what we call the scale. You stand on the scale, and then you know what you are weighing. If I want to weigh the mass or the weight of this marker, I have to use, in physics lab, I have to use the spring balance. The spring balance is an instrument to measure mass. And remember, I said mass is in kilograms. Mass is in kilograms. That is the standard unit for mass. Is in kilograms. Mass could be in grams. What's the mass of this? Let's say this bag of rice. Some people could say it's 50 grams. but the standard unit for mass is in kilogram. So if I have a mass, an object that is weighing 50 grams, I have to convert it to kilogram because the standard unit for mass is in kilogram. Then mass could also be, I want to measure the weight of, let's say in the lab we have what we call different masses. It could be 5 grams, there will be 5 grams, 10 grams, depending on how weighty it is. Then the spring balance has a hook. I just hook it. The spring balance is on the screen there. You just hook one of the edge of the mass of the body you want to measure, and then the spring begins to move, dangle down. So the weight, the spring balance also has a scale, just like the meter rule. So where it ends, you trace your reading. You trace your reading. But when you are doing any reading in the lab, whether you are using the meter rule, whether you are using the vernier caliper, whether you are using the micrometer screw gauge, or using spring balance, you must ensure you avoid error due to parallax. You avoid error due to parallax, especially for those who want to write their WIAC exam. So when you are doing your practicals, you'll be asked, what are the precautions you took when performing an experiment? And one of the precautions you always take in practical class is to avoid error due to parallax. So when you're taking reading, you don't bend to one corner and taking reading from the meter. Your reading will not be correct, not be accurate, or you are bending over and you are leaping over. So you make sure you are staying and upright to look focus on whatever you are measuring. If the spring balance, the scale is there. If it's a vernier caliper, you are properly positioned, placing your hand on the instrument you are holding to measure correctly. So you don't bend to work on it. So one of the precautions you take when doing experiment in the lab is to avoid error due to parallax. So that is that for maths. Then, and I say time is also one of the most important. I named them before we started: mass, length, and time. We have dealt with length extensively, and then mass using spring balance, chemical balance, as the case may be, whatever you want to measure. And remember, it is in kilogram. Very, very important. Then time could, the SI unit for time. Remember in the last class we talked about the fundamental quantities and their unit, and I said time is measured in seconds. Time is measured in seconds. So most of the time we use abbreviation. So if I put seconds, it's okay, it's not wrong to put it in words, seconds. So but we are growing, we have to learn from simple to complex, then from known to unknown. Now you see, time is in seconds. Time is in seconds. So you put it, as a physics student, please we learn to abbreviate it. It is better that way. Time is measured in seconds. Time could be used, you can use a stopwatch. Those athletes who do weights, but they want to measure the how fast this let's say somebody is, or how fast this person is. You see them using a stopwatch to check the timing, and you can also use your clock. You can also use your wristwatch. These are instruments for measuring time. And also we use stopwatch in the physics lab. We use stopwatch to measure time. I want to check the number of oscillation. I'm doing an experiment on electronic state, for instance. I want to check number of oscillation of a pendulum bulb. It's expected for me to use a stopwatch. So the instrument for measuring time in the lab is stopwatch. 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 Stopwatch is the instrument to measure time. And remember, you could measure time also in with your wristwatch, the wall clock. Some people use their phones. You set your time using your phone. But in an exam condition, you are expected to use a stopwatch. And that is that. And don't forget that the time, the SI unit for time is in seconds. Time could be in minutes. Time could be in hours. So, but if I'm given time in minutes, I have to convert from minutes to seconds. If I'm given time in hours, I have to convert from hours to seconds. And remember, we normally read when we're in primary school or when we're in junior secondary, 60 minutes, 60 seconds, make 1 minute, 60 minutes, make 1 hour, as the case may be. So we're seeing it then. It comes into play now in physics. Remember, measurement in physics is very, very important. So if I have if I have given time in 5 minutes, I'm giving 5 in 5 minutes. Because the standard unit for time is in seconds, I must convert to seconds. So what do I need to do? I will say 5 times 60, which is 300 seconds. So 5 minutes is 300 seconds. So I have converted 5 minutes to seconds because the standard unit for time is in seconds. If I have my time, let's say after performing an experiment, I want to check the number of oscillation of this pendulum bulb in my retort stand. It's okay, is for every 10 seconds, what's the timing? And it's in seconds, you don't have a problem. But if it's in 5 minutes, and I'm asked to calculate the speed, let's say for speed of a car moving, or calculate the distance, and I'm giving 5 minutes. Remember that time is in seconds. So what do I need to do? Convert my 5 minutes to seconds. And how do I do that? Say 5 times 60, because 60 seconds make 1 minute. So 5 times 60 is 600, 300. So 300 seconds is in 5 minutes. So if I'm giving 5 hours, I will leave my answer in hours because my unit in time is in seconds. So I have to convert 5 hours to seconds. So how did I do that? I will say 5 times 60 times 60, which is 60 seconds make 1 minute, 60 minutes make 1 hour. So I say 5 times 60 times 60 give me, so in other words, 18,000 seconds is in 5 hours. 18,000 seconds. So 360 seconds make 1 hour. 360 seconds make 1 hour. So if I'm converting from hours to seconds, I have to multiply by 60 times 60. So if I'm converting to minutes, it's just a number times 60. I'm converting 5 minutes to seconds is 5 times 60. Converting 5 hours to seconds is 5 times 60 times 60. Is that clear? It's because 60 seconds make 1 minute, 60 minutes make 1 hour. So 3,600 seconds is making 1 hour. We are done for today, and before we go, let's have a recap of what we have just been taught today. And if you're just joining us, you can still pay attention. You can get something from here. And we started with identification and uses of measurement. And I said that the 3 most important basic quantities in physics are mass, length, and time. And I said length can be measured using a meter rule, using a vernier caliper, and using a chronometer screw gauge. Those instruments are used to measure length in the lab. We use meter rule, we use micrometer screw gauge, we use vernier caliper, and then vernier caliper could be into 2. We have the engineering calipers used by the engineers, and then the vernier caliper is the one we use in the lab. And then we have to talk about, so using meter rule can measure length that's a flat surface length, although that is not round, that is not cylindrical. You straight, let's say the length of your board, the length of, let's say, you place your variant board you place your meter on the board on your lab. I want to measure the length of placing a mass placing the mass on the meter. I want to check the length. The object you are measuring should be an object that is not circle or not cylindrical. So I will use the meter rule. And then the meter rule has a graduation of 1 millimeters or 0.1 centimeters. And then we talked about vernier caliper used to measure the internal and the external diameter of an object. I want to check the length of this marker, for instance. Like I said, I don't have to use a meter rule. I won't get an accurate reading. So I have to use the vernier caliper because it can also measure the diameter inside this. If I remove the cork and I want to measure the diameter inside this marker, I use the vernier caliper. And then I said it has 2 scales, the vernier scale and the main scale. And we did a lot of calculations today, and we talked about how we can measure, give an instance, how we can calculate using a vernier caliper. And I said in the main scale, I have to check where does the main scale coincide with the line in the vernier scale. And I also have to check the last line, how does the main scale enter the vernier scale, and when does the main scale coincide. What are the 2 points I have to take note in calculating reading in the vernier caliper. And I also talked about micrometer screw gauge. So micrometer screw gauge is also used to measure length, diameter of an object that has to do with an external part of the object. I want to measure the diameter of this marker, so I have to use the micrometer screw gauge. I don't have to go to check. I really check the diameter inside, not the external. Only the external part of the object I'm measuring. I use the micrometer screw gauge. It also has 2 scales: vernier scale, which we call the micrometer screw gauge scale, and the main scale. And the main scale, it has the same way we calculate the vernier scale, the same way we calculate in the micrometer screw gauge. But the difference is in their diagram. Where does the main scale enter into the vernier scale, and how does the main scale coincide with the line in the vernier scale? So if I'm doing that, I'm getting my actual reading. I remember that the vernier scale is in millimeters. So whatever I get, I have to convert it to centimeters. Very, very important. And mass is also what we discussed today. The instrument for measuring mass in the lab is the spring balance. So this chemical balance in the chemistry lab, and as the case may be, and the unit for mass is in kilogram. And lastly, time. Time is measured in seconds, and we can use instruments like stopwatch, your wristwatch, your wall clock, even a sand clock. In those days, they're using sand clock to measure time. You pour sand in an instrument, and then somebody begins to count for you. And then until the sound goes through. Sound clock is also an instrument to measure time, but both is in the past. And for now, in the lab, we use what we call the stopwatch. So don't forget that the SI unit for time is in seconds. And lastly, we talked about how we can convert from minutes to seconds and from hours to seconds.